that. Oh, look at this. I'm going to write down something I wouldn't even told you, and I don't know how I missed it before. In a repeating decimal, first of all, how do we show a repeating decimal? A repeating decimal, how do you show that something repeats, Nick?
The little line thing.
Let's say you've got 0.27 with a line over it. Or let's say you've got 0.27 with a line over it. Is there a difference between those two things? Yes, there is. Okay. The line goes over the digits that repeat. So in this case here, if you were to write this out, it goes on forever and it looks like this. 0.27, 27, 27, 27, 27. And since I don't want to waste your entire life, we're going to stop with that. We'll put 3 little dots there. It goes on forever. Okay, in this case here, it's only the 7 that repeats. So it's 0.2, 7, 7, 7, 7, 7, 7, 7, and boom. Okay. Some things to watch out for when you see repeating decimals. If you see 0.6666 and the repeater's right there, okay, the more simplified way to write that would be to do what, Jeremy?
0.6.
Right, since these are repeating 6s as well, you don't need all those 6s there. Just put the 0.6 repeater. Which means you would see that and you would look at your little notes there and tell me what fraction is that. Sage Hyde. 0.6 repeating is
2/3.
equals 2/3. You should see that on your little thing there now. Now please note, all repeating decimals come from a specific fraction. Okay? Come from a specific fraction. For example, 1/6. How do I change 1/6 to a decimal without looking at my little sheet that you already have there? Lauren? What's that? Yeah, but 6 doesn't go into 100, so you don't know what goes on top here. Okay, and that's the thing with repeating decimals. They don't go evenly into 100. So the only way really to do this is divide the bottom into the top. Okay, so you're going to put a 1 with a whole bunch of zeros after it and do the division problem. 6 goes into 10 once. 6 goes into 40 6 times. 6 goes into, once you start getting this digit that repeats, I'm just going to keep getting 40s and 36s here. I know that this 6 repeats, and I can put my line above that 6 there. So the decimal equivalent of 1/6 is 0.160. Okay. Now, when you do a story problem that has numbers in them or like this, you always want to try to use the fraction if it's a repeater, because there's no way I can multiply something by 0.6 repeater. Okay, because you'll always end up with some long decimal number that you wouldn't really get. Fractions are always more exact than decimals will ever be. Now there's some decimals that are exactly the same as fractions, okay, but this fraction is much more exact than this decimal would be, especially if it's a repeater. So when you come to a story problem, you definitely want to try to use the fraction given the choice, or recognize that the repeater is some sort of a fraction. That's why I gave you the little sheet there, the easy ones that you should know. For example, this one here, 0.8 repeater. Anybody know what the fractional equivalent of 0.8 repeater? It's just like, here, I'll give you this, 0.7 repeater, 0.6 repeater, 0.5 repeater. What are those fractions? What is the denominator going to be on all of those? John? 9. Right. This is the same as 7/9. This is the same as 6/9, but you say that's 2/3, and I say yes it is, because if you reduce it, it's 2/3. This is 5/9. This is 8/9. Okay. There's some that after you do a lot of math, you start to recognize right off the proverbial bat. Jackson?
What if you're doing, like, say a repeating, if it's a fraction and it's a repeating symbol, what if it's like 1.16 or 1.5? What if it just keeps going?
Well, that's an irrational number. If it doesn't repeat, and it never ends, it's an irrational number, and that comes from square roots. Okay, they won't ask you to do that. If they do ask you to do that, they'll tell you to round it to X amount of digits, which might be something we talk about. Round 0.36 to 3 decimal places. Okay, how do you round 0.36 to 3 decimal places? Well, first of all, what's it mean, 3 decimal places? Jeremy Swartz, what does 3 decimal places mean? What place would you be rounding to if it was 3 decimal places?
10,000s.
I don't think so.
All the way from thousands.
Yeah, the thousands place. You can start by doing this. This is the tenths, the hundredths, the thousandths. The 3rd decimal place is this. But in order to round this number, you need to know what the next number is, because it's either going to stay a 6 or go up to a 7. In this case, it's going to do what, Corinne? Right, so to 3 decimal places, this is going to be 0.367. All right, now you're going to say hey. Nobody said hey? Hey, what's that mean for our assignment?
We're gonna use A.
We're gonna bake it. So we're saying half relatively a thousand.
That means on your assignment, let's see what they ask you here. Lauren?
Can you put like a repeater sign over a whole number? Or does it have?
No, those numbers be repeated over whole numbers, because whole numbers really, you run out of decimal. You run out of places until you get to the decimal. You mean like if you put, well, let me get this up first. I think I know what you're asking. What lesson is this? 30, right? So it would be under 3.
Like if you have like 36,600,000.
Well, no, the repeaters only come after the decimals. I think I know where you're going with that, but no, you would never have that, and then it would just keep repeating forever, even before the decimal. No, never heard of such a thing. In all my years, never heard of such a thing. All right, let's see what they ask us here. Ready? No. There we go. So, here is the questions that you're going to get. Write each fraction as a decimal number. Letter A. Okay, again, use the resources you have. Do we have 11ths on our sheet?
No.
Okay, if you don't have 11ths, then there's only one way, and that's the hard way to do it, John, which is to do what?
You have to divide
You're going to have to divide the bottom into the top. Okay, and generally speaking, they will repeat at some point. Sometimes it's a whole bunch of numbers that repeat. So you sit here and you go, okay, 11 goes into 30, what? 22 times, or 2 times, which is 22, and then you get 80, you get a 7, which is 77, you get a 30, which is, now once you see, okay, I started with a 30 here and I ended with a 30 here, what's going to keep happening? I'm going to keep getting 2s and 7s. Guaranteed if you keep doing that. For my answer, I need to write what? Anna Nuzzo? It's going to be 0.27. Where's the line go above? What repeats? The 2 and the 7. 2 9ths, you already have in your notes. You should know it is what? Nick?
0.22.
Letter C, 2 2/3 as a decimal is what? Lucas? 2.3. Nope. 2/3 is what repeated? Reference. Brandon?
6.
Make sure you put the line above it. 1/30th. Again, we don't have it in our notes there. It will look familiar when you're done with it here, though. You have to take 30, divide it into 1. Watch your zeros here. 30 doesn't go into 10, so there has to be a 0 there. 30 goes into 100 3 times, that's 90. Into 100 3 times, 3 times, 3 times. So the decimal is very similar to 1/3, except it's 1/30th. You just have to put a 0 in front of that. That's your repeater for 1/30th. I'm guessing these are all supposed to have little lines above them. It doesn't copy them on the board here, but you should do that. And then the rest here, you should be able to figure this out. Best way to get these, to figure out if they're bigger or smaller, there's a couple different ways you could do it. Lauren? Yeah, I would change them all to decimals. Why? If you change them all to fractions, it still doesn't give you a clear thing there. 1/2 is 0.5, 0.5 repeater, 1/3 is 0.3 repeating, and then there's a 0.3, and then there's a 0.06 repeater. What is the smallest of all of those? Smallest one, Nathaniel?
0.06.
0.06. What's the next smallest? Lauren? 0.3. Then it goes to Nikki Kyle, what?
0.3 never endings.
0.3 repeater, and then obviously 0.5 and then 0.5 repeater. Sorry, that should be there. Which brings up the joke, Keaton Repeat went